A political residence presents an immediate operational paradox. It is a high-threat environment demanding absolute security, yet it functions daily as a high-traffic working building. This generated footage illustrates the baseline problem of scale. During morning arrivals, hundreds of staff, officials, and deliveries pass through a single perimeter gate, presenting a constant, indistinguishable flow to standard security cameras. Traditional physical security relies on checkpoints to manage this volume, operating on the assumption that securing the perimeter guarantees the safety of the interior. But a perimeter badge swipe only proves that a specific piece of plastic unlocked a door at a given time. It offers zero data regarding where the actual human body attached to that credential went afterward. This security view shows the ThinkEye operational model. Raw video feeds are ingested and instantly organized into tracked, categorized identities, applying a distinct bounding box and an access tier to every individual in the frame. Securing a facility of this profile requires moving past intermittent checkpoint clearance and maintaining a continuous, frame-by-frame state of identity verification. As this graphic illustrates, protecting a political estate requires abandoning estimation in favor of absolute, real-time spatial accountability. Government deployments at this level operate under strict technological constraints, primarily the absolute requirement for data sovereignty and the prohibition of off-site processing. This network flow diagram maps the local architecture, 54 distinct camera nodes funneling data directly into a localized, air-gapped Ubuntu server stack inside the compound walls. Because this environment is isolated, no video feeds, biometric models, or audit logs ever touch cloud infrastructure. This table maps the 5-tier access model. Color codes define categories like family or staff, operating as logic gates. Amber credentials expire outside working hours. The cyan tier utilizes an escort tether, triggering instant alerts if a visitor and their assigned escort physically separate. Applying this logical topology turns a chaotic physical environment into a structured, rule-based database. To maintain accuracy, the architecture processes individual frames from every camera 60 times a minute. Before a detected shape is counted as a human face, it passes through a multi-stage filter pipeline. Skin region validation and dual eye confirmation run simultaneously to strictly reject false positives, keeping posters, screen reflections, and harsh shadows out of the telemetry. This precision addresses the classic vulnerability of computer vision systems in dense environments, the tendency for identities to swap when crowds intersect. This animation shows a complex occlusion event. As bounding boxes collide and visually block each other, identity tracks are held in memory, never guessed. They maintain their assigned data through the blind spot, reattaching the persistent ID label only upon strict facial re-verification after separation. By refusing to interpolate missing data during visual interference, the platform guarantees a defensible chain of custody for every human in the facility. We can observe the system's stress capacity by examining how it processes a multivariable incident during peak midday occupancy. The physical catalyst is an opportunistic perimeter breach. An unenrolled individual tailgates through a closing heavy door at a service entrance. This split-screen dashboard shows the system processing 2 events simultaneously. On the left, a yellow alert flags a staff member stepping out of their authorized zone, a mundane policy violation. On the right, a red alert tracks the unengulfed figure at the door, an active, severe threat. In under a second, the Level 1 escalation fires, delivering a command center notification with evidentiary face crops already attached to the alert. As the threat progresses, Level 2 escalation automatically locks the nearest PTZ cameras onto the subject and pushes instantaneous webhooks to the protection details dispatch console. Simultaneously, the persistent ID timeline allows the command center to instantly reconstruct the threat's backward path, identifying the specific vehicle they arrived near. The critical Level 3 trigger condition is met when the unknown individual's approach crosses the digital buffer of the inner residence wing. This 3D map illustrates the containment response. Red hatching indicates the central residence wing sealing instantly, isolating the threat while outer zones operate normally. The AI doesn't physically lock doors. It acts strictly as a trigger, firing a pre-authorized webhook to the facility's independent access control hardware. Automated incident response remains secure only when its actions are proportionate, hyper-localized, and strictly subordinated to pre-authorized human protocols. To understand the integrity of the ThinkEye architecture, we must look at the specific analytical capabilities it intentionally rejects. There is pervasive industry pressure for security systems to include behavioral inference, attempting to predict a subject's intent by analyzing their facial expressions. This interface highlights aggression detection and voice stress analysis, tools excluded from the platform due to demographic error rates and a lack of reliable scientific basis. Beyond technical flaws, utilizing biometric emotion inference in high-risk environments violates strict legal frameworks, placing it directly against prohibitions like the EU AI Act. This timeline log displays the defensible alternative. Instead of pseudoscientific emotion tracking, the system relies on observable topological facts, a 14-minute dwell timer overrun, or a verified escort separation. These objective metrics provide undeniable, auditable evidence, precisely what an incident review board requires. To remain tactically reliable and legally defensible, security at this level must rely entirely on physical logic, not biometric pseudoscience. At the end of the daily operational cycle, the focus shifts from active spatial tracking to departure reconciliation. The overarching operational goal of a protection detail is achieving verification zero, leaving no individual unaccounted for when the shift closes. This departure board visualizes the reconciliation mechanics. The live on-site counter scrolls rapidly downward as the system ensures every exit closes a specific entry log and that departing vehicles perfectly match their morning occupant manifests. In these environments, the system functions as a massive ingestion and evidence packaging engine, prioritizing human oversight over autonomous decision-making. Final accountability, action authorization, and alert overrides always remains tethered to an identified, logged human operator. And as this isolated server rack illustrates, the entire sovereign architecture, from continuous tracking to localized lockdown, exists completely within the facility's own walls. Ultimate physical security is achieved by building a continuous, localized audit chain where every person is accounted for, frame by frame.